Good evening, friends. Greetings from GeoVigyan. We hope you all are doing well. And myself, Shubham, on behalf of Team GeoVigyan, I welcome you all to this chapter 1 of remote sensing and GIS training, in which we will be learning about application of machine learning algorithms using remote sensing images. And before I introduce our instructor for this 5 days training program, I would like participants to know you some of the key details which will be helpful for you. That for all 5 days we will be going at the same time live on YouTube, and you can ask your doubts in the YouTube chat box, which will be taken at the end of the session each day. And also, if you have not registered yet for this course, please go through our Telegram or WhatsApp channel and find there the registration link. And we will be having a mock test on 15th of October on the same time, where you will be shared a link for test through your email ID, and you have to attend that test in order to get a certificate. So now moving towards our training instructor, Mr. Sabyasachi Kabiraj, who is a research scholar at Anna University, India. He is working as a he has worked as a SRF in ICAR-Central Institute of Brackishwater Aquaculture since 2017. He has published multiple international research articles in Elsevier, Springer, Taylor and Francis, and Wiley. He has also attended multiple international and national conferences. He has also worked as a project assistant in IGCAR Kalpakkam. So, with this a brief introduction of Mr. Sabyasachi Kabiraj, I would like to call Sir to please take on the stage and follow up with that session. Over to you, sir.
Thank you, Subham, for your nice introduction. So I'm sharing my screen. Please let me know if you are able to see my screen. Yeah, is it visible, Subham?
Yes, sir, it's visible.
Yeah. So good evening to all, and I am Sabyasachi Kabiraj, and the topic is application of machine learning algorithms using remote sensing satellite image. And this is the 5 days work plan, and the very first day we will see the Google Earth engine. Little bit we will see the introduction of Google Earth engine and remote sensing, and the second day we'll have a basic understanding about the GE codes, what are the basic algorithms or syntax in Google Earth engine, and then we'll learn about the satellite data import, like how to import the data of a particular time series or a particular satellite data, and we'll see how to display on Google Earth engine platform. And the day 3 we'll learn the GIS data import. Here we are going to deal with the GIS data import in the sense of vector data, and we'll try to import that shape file or KML or whatever it is that in Google Earth engine platform, and we'll try to visualize that. And after that we'll try to learn some of the basic algorithms which are available in Google Earth engine platform. And in the day 4 we'll see the various applications of random forest model. Especially this is the one kind of machine learning algorithm. There are multiple machine learning algorithm. Among all the algorithm, this is one of the best machine learning algorithm which we are going to see, and its various applications with case studies that we are going to review. And after that we'll have a practical demonstrations of that particular random forest model, and finally we'll have conclusions and question and answer session on the day 5, including all the day's questions we will take that day. So starting from the very first day, so this is introduction to GE and remote sensing. So what is actually Earth engine? So here we can see it's a cloud-based geospatial platform where we'll have petabytes of satellite images storage from various agencies, and this is the data center you can visualize in the background, which is developed by Google, and it is one of the open source platform. Anyone in the world can access this data by creating a simple account, user account, and through that they can access the data whatever they want. And what kind it is depends on the analysis. Based on the analysis we need to select the data products, and finally you have to import it, and anyone can access it. So it's a kind of open source, and commercial versions also available, and that is most advanced level Earth engine product. So coming to the satellite data products, here we can see 2 to 3 different kinds of satellite. Here Landsat, we have entire Landsat series, And then mode is, then we have terrain data of SITM, NED, and it is a lot of terrain data are there. It's not only SITM, it's not only NED. There are different things are there. So for that detail, I will show you in our next slide. So again, coming to the land cover data, we'll have the global land cover data and then NLCD data. And for atmospheric data, related data also, it is there in the Earth Engine platform, which provided by NOA and NCEP. So these are the things that are available. And from the very first slide, I'm talking about this, the power or strength of Google Earth Engine. So we can see the computation engine is a just in a time distributed computation model, a cloud based processing infrastructure. So everything will happen on cloud. You just have to put the algorithm, just type the algorithm or write the algorithm, and it will give you the output in a fraction of second. So it's a very powerful engine, we can say, and it is developed by Google. And here we can see the different grids of the satellite data. It is grid based actually. So we will take each tile of a satellite data and then we'll run the algorithm through this CPU, and finally you will get the output. So what are the benefits actually you are getting from Google Earth Engine? So it's good for projects that requires large number of data and extensive data library. And if you want, it is require high speed of computation or calculation time. So it will calculate your algorithm or it will give the output within a short period of time. And no need of very high level of laptop configurations or like RAM, or it does not depend on those kind of things. Only you need is internet. So if you have internet speed, that's enough for Google Earth Engine to calculate. And intensive processing capacity and advanced raster processing tools. So some of the limitations also there. So among the limitations, the one of the major limitation is it's better to do the kind of image calculation, like image processing things we can do with Google Earth Engine, whereas we can't deal with the vector-based analysis in Google Earth Engine. So that is the main drawback, one of the main drawback of Google Earth Engine. The second one is analysis based on pixel spatial relation are harder to complete because of the processing on multiple CPUs. So image segmentation and hydrologic modeling options are very limited. So for that, we need a separate kind of algorithm. So if you are able to develop the algorithm, you can do. But by default in Google Earth Engine, we have very limited tools available. So for example, if your project goal is to find out the changes between 2000 and 2010 within a specific time, a specific region or region of interest, and if you want to calculate the degree of changes and year of occurrence, so how you accomplish this task? So in traditional method, what we used to do before the Earth Engine development, so first we will select the area of interest, and through that we'll get the raw path number of a satellite image. And here assume that your area of interest covering 4 scene, or you can say 4 satellite tiles. And after downloading the data, here we can download and store the data in our computer is own storage or local drive, and then we'll try to extract, and then we have to do the layer stacking, then mosaicing, lot of things we have to do step by step, and then finally we'll do NDVI analysis. And we'll basically we are using ERDAS or ArcGIS or whatever it is, or QGIS, whatever it is you are using, and finally you are identifying the pixel based changes in that particular locations between a different time period. So this is a huge task. So if you see, this will take around 1 to 2 months if you do proper analysis. But the advancement of the satellite image processing in Google Earth Engine, it will hardly take 1 hour. Just you have to write 100 lines of code, and you don't have to, no need to download the satellite image, or no need to process it. It is already there inbuilt. No need to do atmospheric correction if you are using level 2 product. So there are a lot of products also developed by Google developers to simplify the usage. So simply you download the atmospheric corrected product and you can use it directly. Or if you want to use the raw product, that also available. So they have given the facility to the researcher, or you can say programmer, to use the various kinds of satellite images with a variety of corrections. So how Google Earth Engine developers are using this? So you can see here, the first one is streamline and sharing the GIS and RS workflows. So the facility of sharing the workflows also available through Google Earth Engine, and the bridge gap between the literature and application. So it is fulfilling this also. And a developer can create a novel methodology for his own model or for his own project, and also it can create an application to deliver data and analysis capability to not Earth Engine users. And here you can see the example of the interface of code editor. Here you can see where I have shown some of the satellite image of Landsat 8, and basically it has shown the true color image. And this is a web-based IDE for the Earth Engine API, which can be accessible using JavaScript and Python. These two programming language only allowed. And this is the interface of Earth Engine, where we can see the left side, we can see the zoom panel over here, and then there is a logo of geometry tool where we can pan, we can make a point, line, polygon features. And then we can see the asset manager, where we can upload our GIS data through asset, and we can share our asset as well. That is also possible. And we can have a script manager, where we can see the reference script already available, and it is given by Google Earth Engine developer. If a developer is stuck somewhere to write the script, the user can search over here in the search window and can find out the expected script. And then we have a huge documentation part as well, API documentation part, and search for data. So this particular panel is for searching the satellite image. So if a user interested in Landsat 8 or Landsat 7 or Landsat 9 or Sentinel-2, whatever it is, or climatology related data, whatever it is, the user can simply search over here and can directly access the data. And then we have a get link to script. So through this, you can share your script link to the other user. Just you have to click in the get link option, and it will generate a unique link ID, and through that you can share to your friends or your work group or your colleagues. And the next one is save script, and it will save your entire script into the script folder. And then the next one is run, and after clicking this, the entire script will run and it will get executed, and all the things will displayed in console bar over here. And you can see there is a tab called Inspector, where using this you will get a plus symbol over here in the interface of map interface, and if you click there, you will get the all information whatever available on that particular locations. And then the next one is console, where the output will appear, will be displayed over here. And the task, if you are giving some task, the progress of the task will be visible over in this tab. And if you need any kind of help from the Earth Engine developer, you can use this help button over here. And right here in the below right side, you can see there is an option called layer manager, where you can see all the layers which you have or the programmers have written over the script, all the layers will be displayed over here. You can tick or untick all the facilities, or you can display the data symbology. You can do many things in this layer using this layer functions. And the pros and consecutions are there. So what is the pros? The allows user to create complex workflows. So if a user want to make his model in a complex way, he can do using the different kind of script. So the script he can design according to his project. So including any data in Earth Engine or using its extremely high speed computation engine. So these two advantages you are getting actually. So first is you are able to access without any obstacle. So it is already linked with the different agencies server or satellite data. So directly you are pulling the data into the Earth Engine code editor. So that is one facility. The second facility is you no need require a high speed laptop or any device to calculate the satellite images. So any kind of image processing. So this will reduce your task in a short period of time. So it will give you a result within a short period of time. So that's the thing, you can get it. And the second one is workflow can be easily shared between users. So this is a very important feature. Whenever some programmers get stuck in between, he can share his script to anyone who is expert on that particular field. And here if you see, it requires a programming knowledge. So without that, it's very difficult to understand the different script. So you should have basic understanding about the programming such as JavaScript or Python, and need to be aware about some unique GE classes or methods. But it's like not that much programming language, in-depth programming language is needed. If you know basics, you can handle it. It's not rocket science, you can handle it. So Earth Engine editor drawbacks. The first is users allow users to create complex workflow. So if you create a complex workflow, the Earth Engine will give again and again error. So those are some of the drawbacks is there that I will show you. And workflow can be shared between easily between users. So this is a kind of advantage and as well as is a drawback, because no one wants to share their personal files. If someone wants to share, that same link can be shared with other as well. So there is a little privacy issue with this. So these are the today's content. So I will show you the Google Earth Engine online view. So just a second. So as you can see here, this is the interface of Google Earth Engine. Okay. So already I have shown you the interface, how it looks like. So after opening or creating an account using your Gmail or whatever it is, you will able to see this code editor. The interface will look something like this. Okay. So in the left panel, you can see there is a option called script. And under this script, you will have all your project detail or script, whatever you have written. all will be saved over in this owner. And you can see some of the example given by Google developer. It will be present by default. And then we have a docs where we can see all the programs. So if you are facing some kind of issues while writing the program, you can search over here. For example, I want to do some kind of image collection I want to call. So just write image collections and you will get all the detail related to image collection. So if you don't know, if you are not aware how to write the code, you just click over here and read the detail, and accordingly you have to write the script over here. Okay, so this is the document given provided by Google Earth Engine developer. And the next one is asset section, and this is actually cloud based. You can see here cloud assets, and here actually we can import our own shape file, KML file, or all the image file as well. So you can see if you want to upload some kind of satellite image or some kind of raster image, so this is the supported format, GeoTIFF and TFR record. So these are the two things in case of image, or in the case of shape file or vector data, these are the files it will support. And if you have a collection of image, you can select this one, and through folder also you can directly upload the folder. So these are the options available in asset section. Okay, so as you can see here, I have lot of different kinds of assets where I have India boundary and then different kind of satellite image. Here you can see the Sentinel-2, and then I have raster, vector, all kind of things are there, right? And now coming into the search view over here. So for example, if you want to search some kind of place name, so for example, Patna, if I want to search, you can see just select the Patna and it will directly link over here. So this is not only to search satellite data, but you can search the place name as well. Okay. So now I want to download, or I want to import satellite image for Patna region, right? So if I want to download, for example, if I want to visualize Landsat 8 data, so just type Landsat and it will give you all the Landsat product. So you have to wait a little bit because my internet is very slow and it will take little time. So this is the place where you can search our data. You can see here, if it is not working, you can directly go over here and you can browse the data over here. So all the data are available here. Okay. So if you want to go with Landsat product, you can click over the Landsat. If you want to go with the Modis data, you can click over here. Likewise Sentinel. And then if you want to view all data sets, it will be present over here. Okay. So here also you can search it, it will come, but as my internet is very slow, it's not able to derive that particular data product. Okay. And the next thing is, this is the get link option. So for example, if you simply put print, and if you put hello GeoVigyan, and if you execute it, so you can see here it is executed. So now whatever you will write over here, through this run option you have to execute, and the execution will happen over in the console console tab. So whatever you will execute, all things will come in console tab. So for example, if I put variable call A and I'm assigning some number 7, and then variable B and I am assigning number 8, and now I want to print something A plus B. So you can see 7 plus 8, it is 15. So it is executed over in the console sections. So this is the script editor where we are writing our script, right? So it is by default. Python also will work some kind of, if you not put variable, then also it will work. It's not necessary that you need to put variable all the time. Okay, so variable must be declared with variable, and okay. So by default it is JavaScript, and if you run with Python, if you want to run in Python script, you should have collaboration, that collab or library, you have to use it for Python. But here you can run only the Java. So here it is showing variable must be declared with var variable, and then only it will execute. So error will be showing over in this console tab. So whatever error you will write, for example, if I put variable, if I don't put variable, so just now we have seen, so I will put something around GeoVigyan equal to 100. Print GeoVigyan. So you can see it is giving me an error where it is telling me that please declare a variable as a var, that is variable. So if you assign var, and now if you run, so it will give you the perfect output. And then this is a get link. So whenever you will click in this get link, you will get a link over here, and just copy this link, and you can share this link with your colleagues or whoever expert in this Google Earth Engine. Okay. And the next is to save the script. So you can save it, just click on save as, and you can write the name, and you can save it, and this will get saved in the script option, and it will save over here in the owner detail. And this already this is the run. So this is the shortcut for run, Control Alt and Enter. And this is to clear a script. So if I write something, and if I want to see, now it is coming Landsat 8, and now it is displaying all Landsat 8 products. So for example, I want to go with this. So the details will be provided here, and the band details will be given over here. All band informations, the resolution and the wavelength, and the description of the band, and the band name, right? So you can see this is a top of atmosphere reflectance product, and also we'll have surface reflectance product as well. So for surface reflectance, we are using SR, or we can put surface reflectance. So we'll get the surface reflectance product as well. So there are a lot of data are available. Just go through this, and whatever require, just import it. So now if I want to import some kind of Landsat 8, I can directly search over here, and I can import it through this. And now the entire image collection imported over here, and I can rename it the variable as a Landsat 8, and you can see the variable name I have assigned as Landsat 8. Okay, very simple. Now here you can see the 17 bands, and the band details are over here. So out of 17 band, these are the different bands which is created by Google Earth Engine user, Earth Engine developer, sorry. And these are the bands. Okay. And the next is app. So if you want to create an app through Earth Engine, you can use this app option. And through this, you can publish your app and you can share your app. Okay. The next is setting. So in this, you will have a suggestion, code suggestion, and autocomplete pair like this, that. So these are the things will be there in the settings. And the inspector, if you use this inspector, so just simply click in any location of in the map, and you will get the lat long and whatever information is available. So for example, I have clicked over here, and you can see the lat long as given over here, and the zoom level and the scale, right? Console, as I already explained you, it's generally the visualization part, or you can say output of the algorithm, whatever you are writing over here. And the task is to give some kind of task to the Earth Engine. So for example, you want to export the output, final output, so that will reflect over here, right? So these are the things. And then coming to the panel of the visualization panel, or it called map panel. So in the left corner of the map, you can see there is a snapping tool, or you can call it panning, that is called pan. Okay, so by using this pan option, you can just move the map here and there. And the next one is to create a marker. It also called point feature in GIS. So just click over here, and you will get a point feature over here. And if you want to change the name, you can change it. If you want to add some kind of label or attribute, you can also add that. So for example, I want to add as a class, so just put class. And if you want to put a value of that class, for example 1, you can put 1. And this geometry also you can change it, so I will put land use, and you can see the thing is changed and it is stored with the value, right? Same way, we have line over the next option. So after point, there is a option called line. So through this, we can draw line. So if you zoom it over here, and if you want to draw a line of this particular road, you can simply draw a line, right? So just you need to double click to finish the drawing. Okay. Now there is a line feature in the land use. You can see there is a point and there is a line. So for example, if you want to create a separate line feature, so I don't want this land use, I want to create separate line feature. So just click on the new layer, and you will get a geometry, another one, and here you can put road, and you can select the feature collection. Here you can put the class name as a 2. You need to put the value, and now if you digitize it, it will appear as a road. So you can see, so by if you see that whatever layer is active, that will appear as a bold color. So here we can see the road layer is in bold color, whether the land use you can see, whereas it is not in bold, so that is not active layer. So whatever layer is in active mode, that layer only going to take this feature. Okay, so whatever we will digitize, it is going to join with the active feature layer only. For example, now I have drawn another line, it has joined with the land use feature line. So you can see 2 lines. So likewise it is there. So next one is polygon. You can see over here, to draw a polygon. For example, I want to draw this forest cover area, right? So you should take the polygon and simply we can draw. So for example, if you like do a mistake like this, you can edit it by clicking in this and you can drag it, right? You can drag the points like this, you can drag it to complete the layer, right? And now you can see, so it is editable format only. We can edit it, we can redraw it, we can modify it. And the next one is to draw a rectangle. So if you want to draw a rectangle, for example, I want to draw a rectangle for this green zone. So I will draw something like this if I want to draw. So you can see this is a rectangle. So this is basically for building footprints we are using, or for taking sample points you can use this. So these are the features available in the map view. And then we have a geometry import. So whatever geometries we have drawn, those things will be there here. And then this side we have a map option, and there is a satellite option, and there is a map option. So you can see in satellite view as well. So this is Google satellite view and this is Google map view, right? So you can see each and every home, and the zoom level, you can see the zoom level as well. So what is the zoom level of this? That also you can inspect through this. So if we click here, it is a zoom level of 20. So the 20 is the highest zoom level in Earth Engine, you can see. So if you reduce it and again if you click it, oh, you can see the zoom level is 18. Zoom level is 18. So if you further zoom out and click, you can see zoom level is 17. So likewise it depends on zoom level. So highest zoom level is 20. Okay. Then coming to the Earth Engine, interface. So this is the kind of interface before signing up into the Google Earth Engine. So you will be seeing like this, something like this. And here you can see the Earth Engine for commercial use also available with Google Cloud. So if someone want to purchase the commercial version, so this is basically, there are different algorithm also, extra algorithm will be there. Like in open source, those algorithm we can't use it, but for commercial version it will be available. Some kind of TensorFlow or advanced artificial intelligence algorithms will be available in commercial use. And also the most advantageous part is the storage part. So Google Earth Engine will give you the cloud storage. So it depends on the cost. So if you want to buy more cloud storage, you have to give the more cost. So it will be costly only. And these are some of the example it is given. So we will have a satellite imagery, and now you have to build your own algorithm. So you have to write the algorithm, and these both will process each other, and then we will get the real world applications. So if you want to see some kind of changes, so here is an option called explore time lapse. So if you click over here, so it will take you to the Google Earth platform. And then we have an option called ready to use datasets. So they have around 40 years of datasets with them, so we can use them for our purpose. And if you want to explore the dataset, you can click over here. The data catalog window will open. So you can see some kind of interface of the Google Earth Engine code editor. It will look something like this. And the publications they had using Google Earth Engine. So these are the publication they have, and this is some kind of scientific and humanitarian impact. So if you click in the case studies, it will show all the case studies related to Earth Engine. So you can see here global forest cover change using Google Earth Engine, and then map of life. So these are the some of the birds related. So how the birds are moving or the biodiversity of a region is changing. So this is the global forest watch, how the global forest is changing over a time period. Then tiger habitat monitoring, you can see here. So there is a forest loss in priority tiger. So you can see this case study as well. There is a malaria risk assessment, you can see. So these are some of the case studies you can see through this. Global surface water mapping, you can see. So these products are available actually in Earth Engine as well. So if you click the study, it will take you to the particular article. So you can see this is published in Nature. So these are some of the features of Earth Engine and their case studies. So if we go to the dataset part, we can see the surface temperature data already available. So you can explore that as well. Then we have climate data with us. We have atmospheric data. Then we have weather data, satellite imagery data. First of all, Landsat series, and then we have Sentinel. And afterwards, we can see the MODIs and high resolution is some of the this high resolution satellite imagery for some of the region it is available, not for whole world. And this is related to geophysical and terrain data. You can see land use land cover data as well available. And this is the cropland data. This is for other geophysical data. So these are the data available in Google Earth Engine platform. So if you are interested in particularly one product, for example, if I try to see only Landsat data, if my interest lies on Landsat data, we can see there is a collection 2, and then we have Landsat 9, the latest one, and the satellite data with their time series as well. So you can see the time series. So Landsat 8, you can see the 2013 to present, and likewise we have Landsat 7, 5, 4. So these are the different mission under Landsat program. So this is the Landsat collection. Same way, if we see the MODIS data, so we can see there is a MODIS data of adjusted reflectance daily 500 meter, and then we have MODIS albedo data, and likewise we have Terra surface reflectance, we have Terra snow cover daily global data. These all are global data only. Same way we have Sentinel data product. So here we have Sentinel 1 and then Sentinel 2, then Sentinel 3 and 5, and these are the derived product from Sentinel. So you can see the dynamic world, and this is the land use land cover data which is derived from Sentinel 2, and it is 10 meter resolution. The pixel size is 10 meter, and this is the world cover. This is also around 10 meter resolution. You can see it's based on Sentinel 1 and 2 data. It's a global cover. Then there is a product called Sentinel 2 cloud probability, where you can see the cloud movement. So if someone interested to study the cloud, they can use this, how the cloud moving and their movement and the area, everything they can calculate. The next one is global map of oil palm plantations. So this is also available. And to know more about Google Earth Engine, you can follow this document part. So you can see by default there is a JavaScript, interactive JavaScript using code editor. So you can use it in code editor. The open source JavaScript library in Node.js. So these are the things. Whereas in Python, we have to use the open source Python library running in Colab. You can see your Python environment or app engine. So this is the environment needed to run in Python. And this is kind of REST API. So it's a new and advanced feature that may not be suitable for all users. If you are new to Earth Engine, please get started with JavaScript guide. So if you are new to the Earth Engine, you can start with JavaScript. So if you want to learn the basics, you can go with the entire documentation part. You can see here Earth Engine already having the documentation part over here. So this is a code editor. You can see how to visualize an image, satellite image. You can see here, and the data structure, the algorithm, and how to add the satellite data into the map, how to display a satellite image. You can see. So these are some of the script already available, or you can say guide from Google developers. They have already given in the API documentation part. So kindly go through it once, and you will able to learn some of the basics of Google Earth Engine product. So you can see band math and all, everything is available over here. And then we have code best practices. So this is some of the best practice to write a code. Those things also given. Just go through it. And here we have development environment, and these are the things we have. So just go through this entire documentation part, and anyhow I will be explaining you all the things in our later classes. So this is for just for introduction part alone, and our later slides, or you can say in our later classes, we can explain all the detail one by one. So yes, that's for today's class. Any questions or suggestions or whatever, you can ask me.
Thank you very much, sir. Sir, you have set the context for this 5 days training. And as of now, I think I cannot see any question. Only one was there regarding a book, what to follow, but you have told the guide, the Google Earth Engine guide. So I think that query is solved. And okay, sir, there is one more question is there. How to use Python language instead of Java?
Yeah, for using Python, you need to already I have explained in the slide. So again, I am showing you the same part. Just a second. So is my slide is visible?
Yes, sir.
So already I have explained that by default Java only will work, and if you want to use in Python, you need to have collab with you, and we should have this environment with you, Python environment, which is given in the documentation part. If you go to the Earth Engine uh, API documentation part. Okay, anyhow, I will be showing you the detail in our later on classes. Okay.
Sir, if you could also please tell something about API. There is a question, what is API?
Okay. So if API is some kind of hosting the data and generating a link, and through that we can access those data to explore the data in different platform. For example, you are making an app, or you are making some kind of mobile applications. Okay, so generally you need data access. So what our developers are doing generally, they are creating data in GIS platform, and those data they are hosting it in some environment, or you can say platform. And after that, hosting those data onto the platform, we are generating a link that is called API link, and through that link we are actually accessing the data from the server where we are hosting our data. And now through this link, you can access all the data which you have uploaded in the server. So generally, this link will create a particular like accessing part of the data, and you can utilize this link in your mobile app development. For example, generally we are searching in Google some places name, or some kind of like traffic, or you can see the red light, green light in traffic, right? Red signal, green signal. So those things actually traffic API, which is already there in backend, which you can't see into the front end. Those data are there in backend. So it's a kind of backend process, but at the same time we are giving a link, and we don't have to take all the data, only we are using the link, and through that link we can explore the data, or we can say we can pull the data into the front end. So that is API.
Thank you very much, sir. I think with this we are done with the questions. I cannot see any more question. So I will request participants to please go through this lecture once again. It is available in the YouTube, so that your more doubts are cleared. And if you want, you can ask the doubts of this session in tomorrow's session also. And please do not forget to fill the attendance form, which is being shared on chat box of YouTube. And please do you need to have almost 3 days. I think my team is telling me 3 days attendance is mandatory to get the certificate and at last the examination. So thank you very much, sir. I think with this we can close the session for today, and we will meet tomorrow at same time. And please do go through that chapter. Thank you very much, sir.
Thank you, Subham.